Hi, this is David Mann with XDI Innovation. Wanted to welcome you to our first technical webinar on Reinvent the Sky, a live webinar. We're live today. I'm here in San Diego. And thanks to everybody for joining. One thing, while we're going through this webinar today, feel free to ask questions. We're going to be talking a lot about what it takes to get an aircraft from concept all the way up to certification. You can ask questions in the windows or in the chat app in the bottom. Also, feel free to react. We always like thumbs up, or if you have things you don't like, let us know. And with that, I wanted to kind of get started. So Reinvent the Sky is all about changing the way in which people have transport or transported. Now, this can also be things like eVTOL aircraft, which is the example we're going to be using today, but it could also be pertinent to the commercial airline industry, which right now is trying to reinvent itself, coming up with new ideas on the way in which people would be transported inside this commercial aircraft. It can also be a way of reinventing the way in which we do spacecraft and satellites, and thinking about how can we do differently satellite launch programs, satellite design, to optimize for weight and package and technology density. So let's move into it really quickly. I'm going to share my screen. Let's see here. There we go. So as soon as that comes up, there we go. Hide that, and we're all set. So with Reinvent the Sky, there's several different challenges associated with getting an idea from concept to certification. But most of the companies that we work with, their main goal is being disruptive. And in order to be disruptive, you need to be able to do a few things. First of which, you need to concentrate on your time to prototype. You want to be first. Getting your name out there first has a huge impact on the market acceptance. Get your name and you set the bar for everybody else. So being able to react quickly and in concert with all the resources in your company is very important. You of course want to be safe, and you want to get your type certification. Almost everything that flies, whether it goes into space, flies in the air as an individual aircraft or a commercial aircraft, has certain regulatory requirements and traceability requirements that they have to meet in order to prove that it is a safe aircraft. You want to be unique. Especially in these days, you want to be able to make sure that you're providing a personalized experience. That the people are able to project into using your product. And specifically to VTOL aircraft, noiseless experience is one of the main concerns that a lot of people want to address. But you also have to think about things like quality and safety. Finally, you want to be agile, because none of this is possible unless you're able to get the funding and the approval from management to do this, or maybe from your investors. So you want to be able to engage them early with digital prototypes. You also want to have a business model when you go to them for investment that says, look, we're not going to be doing a lot of capital expenditure. We're spending most of our money on people and IP. So you're really going to be looking at a rental business model for the software you're going to be using, which fits in great with the XDI and Dassault Systems cloud. The whole idea is that you rent the software and you scale up as you need it. You can also scale back when those burst modes are done in your business, being able to move forward very quickly and at the lowest cost. So the Reinvent the Sky solution, there are four main areas of the solution. First of which is concept definition and validation, where we're going to think about what do we need to make and how do we validate that that is the right thing to make. We're going to move into collaborative execution about how do you organize all the resources in your company and make sure that they're all focused on the right thing and doing the right tasks to get the job done as fast as possible. Once again, time is money. And if everybody's aligned, you're able to get that through much faster. On target execution, making sure that what you design is meeting your requirements, making sure you have full traceability into it, and that you're able to meet or exceed the KPIs that you set and the business objectives in terms of cost, weight, etc. on your product. Finally, once you've actually arrived at a product, you want to start planning for how you're going to grow it. So what is it going to look like to manufacture it? How are you going to do your assembly processes? What are the options available for things like additive manufacturing and component sourcing? So we'll touch on a lot of these concepts, not all of them. As you can see, there's a lot of different areas in there. We'll touch on some of the main ones. And then if you have any questions afterwards, we can take it up after this. So here, let's step into the 3D Experience platform. Here, we're going to log in. Most users, when they come into the 3D Experience platform, are presented with their dashboard. Here, every user in the system is going to have access to a collaboration space, a community where they can post information, they can post videos, 3D designs, they can comment on it, they can like it, and that allows some unstructured collaboration inside the project. People are able to see what other people are working on. They're able to post ideas, maybe try different things in a very unstructured, very highly collaborative environment. At the same time, the platform also provides ways to keep track of what's going on in the world. So you can have all your news feeds and things like that built into the platform. It's just something very nifty that allows you to get up to date with all the different changes that are going on with your competitors, but also with other innovators in the industry. Now here we move into more the project management side of things. So we look at a project. This is our overall project for integration. We see we're in Q3. We're kind of in the manufacturing planning section. This is the view that a project manager would usually use with a work breakdown structure, milestones, gates, sign-offs, approvals. We're going to add a user to this task. And we can see what his workload is like over the various quarters that he's doing, so we can do some workload balancing. Now, on the user side, usually they're not going to be working necessarily in a work breakdown structure. They're going to be more seeing their tasks in an agile fashion. So here the user opens up his task. He's able to look and see what all the descriptions, what the project is related to, what this task, he can set his % complete if he's already started working on it or as he moves through it. You can see either himself as the assignee, he may be able to assign other people if he has the right permissions, but also the attachments and deliverables. The attachments are things that come into the process, and the deliverables allow him to link his actual deliverable to that task. And he's able to do drag and drop to move from a to-do to in progress with a very easy to use interface. Now, as we move into the concept definition and validation, we're really looking at how are we going to design the system of what we want to create. The most important part in any large project is making sure that we have all the requirements and going with the system engineering approach. So with that, the 3D Experience platform gives us a full systems traceability module. And this allows us to go in and drill in and make sure that we're not going to actually miss anything. So if I'm going to be a systems architect on the eVTOL project, I can go jump in directly into an area, or I can see an overview of, for example, different domains like the services that might be necessary for the eVTOL, or the projects, other projects that are running around it, or the standards. Here we're digging into the operational domain. We can take a look at some of the operational structures and how they report up and how they mix together. Now, this is all part of the systems design and systems architecture. It is using a SysML modeler built into the platform. We can see here the different processes, the different user processes, Workday, one simulating a user Workday. Now, we can also take a different look at that system by looking at it in terms of the passenger example. So we can see how he's going to be going from home to the car to the airport by car. We can define and make sure that we have all these different parameters and what his user experience is going to be like in order to use the eVTOL to reach his office. Finally, we can organize it in a slightly different manner. Oops, there we go. We can go over and look at the systems traceability in a full granular model on the overall system. So here we have the different domains, the problem sets that we're anticipating to reach, the solutions, and a grid for the requirements, behavior, structure, and parameters that are going to go into this system design. Let's drill down to the system structure. So this is going to let us define all the functions, requirements, and architectures that we're going to need in order to meet product specifications and expectations of our customers. Now, once we set out all the system design and the traceability, and we know what we're going to be building, our industrial engineers have gone off and come up with two kind of designs that they've got in their heads that we might want to look at. Now, we want to look at whether we're going to be using some maybe tilt engines or fixed rotors. We're going to look at fixed wings or not. There's only one real way to tell, and that's to run simulations. Simulations allow us to test out these ideas without having to build them up front. So here we're going to look at several different types of simulations that are available on the platform. These simulations have been run and set up by an analyst using Simulia. And this one in particular is the wing stress design. So what is the flex and deflection on those wings as it's going through the air, and how far do they actually move out? We can see this as any user in the platform, so we don't need to be an analyst to see this. We can look at those result sets, and then the engineers can work with the analysts to take the right ideas, take the right actions in order to fix any problems that might come up. Here we're looking at a slightly different view. Here we have the vibrations and seeing the effects of those different vibrations at different points on the overall structure. So where are the extremes in those vibrations, and how do they affect the structure? We can go and we look at it in 3D. We can take a look from any standpoint, zoom in, zoom out. And we can also get information about the simulation itself. So we can go down and look at the information about it and see, is there what type of simulation was run, and make sure that we're looking at the right data. Now, there are a few things that aren't yet in the platform. There are tools from Dassault Systems. So here we're looking at a simulation from EXA, the EXA brand, showing the sound pattern, the acoustic pattern of this drone as it flies through a cityscape. Where is the largest impact going to be, and what do we need to do in order to reduce that sound signature? So here we see it flying over. We see the sound signature both on the buildings as well as on the ground. We'll be able to estimate how that's going to impact pedestrians and also businesses in the area if we wanted to have a delivery service or something flying close up. Now, once we have that data, we can go in and we can use XFlow to actually do a simulation and find out where that sound is coming from, usually from turbulence flows. So XFlow can help analyze the turbulence, for example, as your flaps are coming in on your drone or on your VTOL aircraft. And then we can make some design decisions to change that and make some parameters to reduce that turbulence. Now, we've done a lot of simulations, and those simulations is a certain amount of investment. It's an investment by experts, and what we want to do is leverage that into a multidisciplinary trade-off analysis process, or commonly known as an alternative study. We bring all these simulations together inside of one orchestration process, and we can score the different KPIs that we have, such as noise, flight range, manufacturability, and we can choose which is the most important for our customer or for the product that we're trying to design. Then that tool is going to go and explore thousands of configurations and simulation results, and it's going to rank them to make the best compromise to meet the mission criteria and program objectives. When the solution's been found, we have enough confidence that we can go forward with this configuration and move on with the actual mechanical development of the project. So now we want to make sure that we've got everybody aligned and working on the same thing and for the project. So we're going to move into collaborative execution. So once again, on the left-hand side, we have the project manager view, but this time we're looking at the certification schedule. So with any project inside of a program, we do have a certification project. You want to make sure that you're able to align all the resources to make sure you can hit your dates on that certification program, but also that you're able to get all the deliverables necessary for it. So in order to ensure that you do hit the deliverables, you can set up your traceability. Here we see a traceability for different roles and sites. We're going to dig down into the certification manager and set the expectations of those deliverables. So here we see the structure. We can see the different ATA structures and how they relate to the A101s and the CFRs. And we can see, as we select different ones, which ones are impacted. So that's the structure view. If we want to take a look at the impact display, we can see that we have actually certain certification test requirements. We can go back and dig down to those certification test requirements, like a hard landing test, and see trace it all the way back to the CFRs that are related to it. So here we take the hard landing test and we move backwards, and we can see what's the impact or what is necessary in specifying that hard landing test criteria and requirement. This traceability goes through the entire product, and you can trace across electrical designs, you can trace across physical designs, system designs as well. Now, once we have an overall design, we set out some requirements. Our requirements may require that we have, first of all, several different tests of our product. So here we have some flight tests and some static tests. We actually have 2 flight tests here, a flight test A and flight test B, all that have been branched off my basic design set. Design set continues to evolve in release B and release C. But I am able to do some branching in order to take copies of those and do my testing and actually freeze the design. At the same time, with the design, we might also want to set in some variability into that whole process. So instead of just making one product, we want to make sure we can adapt it to meet the needs of different users, so different user communities. So we might say that we have a different user bases like an EMS or a VIP transport. We can specify those as variability criteria and then use that to create different configurations of the aircraft. Some of those criteria might be required, and some of them might be governed by rules that we set down. For example, certain requirements you have and configuration requirements if you're running in US airspace. Now here we dig down into an order that we have, and this particular order comes in and they have a requirement for a VIP transport. Do they want air conditioning or not? We can select it here. We can basically use this product configuration process to drive the physical product configuration of what will be built coming out of manufacturing. And that also allows us to have a 150% design space and a configured product design without having to replicate that design every time we have a new order. So once we know what we're going to build, we know the configurations that we're going to build, we need to actually get down and execute that build. Now in the next sequence of this process, we're going to do a weight analysis, because weight is a critical factor in the aerospace industry, and especially for VTOL design. It has a direct impact on the profitability of an aircraft or a space module that's going to be sent up. Anything that flies has to carry its own weight and expend energy to do so. We'll then investigate, once we've understood the weight, we will investigate ways that the 3D Experience platform can help companies reduce that weight and therefore improve the performance of their aircraft. So as we move in, we're going to take a look at the weight of different evolutions of our product. We're going to start with evolution C, which is currently open and in the design process. We see that we're slightly over our weight criteria, so we're at 1,400 kilos, which is 45 kilos over what our target was. Now with this, with the weight analysis, we can actually dig down in and we can take a look at different parts of the structure and see which parts of the structure contribute the most to the weight. We can also look at how much of those structures have actually been reported. So of course, when you're doing weight, there's the estimated weight, but there's also the reported weight and measured weight from coming in from your suppliers. So here we see that we're actually still missing quite a bit of weight information. And that's something that the project manager is probably going to want to take into account. Now let's take a look at the previous revision, which is revision B. It did weigh less. So we see here, if we're just looking at it, we can see that it did weigh less, but what we might want to do is do a comparison between the two and add it to a comparison table and do a weight comparison and see what our trends are. It doesn't look like we're in line, so it seems like we've got some actions we need to take in terms of reducing the weight of this aircraft. Otherwise, if we continue on this trend, we're never going to be able to fly. So one of the first areas that we can look at is looking at some of the common parts. Here we've got a bracket using an aerospace product. And what we're going to do is a topology optimization. So we're going to set some constraints on it. We're going to introduce what forces are on that bracket and explain that to the system. We have a very simple wizard-based menu to go through and set these actions in order to set the fixation points. And then we say, you know, out of that space, how much do we want to reduce the weight? Let's say we want 15% of the mass of that object based on the design space that we've given it. And we ask it to go through and do that optimization. There are certain constraints we might put in, like symmetry constraints and other constraints that we can put in to make sure that we guide the system in order to generate the right geometry. So what we're doing here is we're not having a designer actually create their own geometry. We're going to use simulation based on the forces that will be exerted on this part to determine what the easiest and cheapest way to design that part will be. We have a lot of variability we can do, and we can actually change various features. So we can change the type of manufacturing will be done, we can change the type of material that is used, and do a different study and see what makes the best sense for our project. Here we're actually, once we've got the simulation results, we can turn it into very easily a part, geometry part. We see this, we see the reflected sides. And just because it's generated doesn't mean that we can't manually modify it. The design engineer still always has the option to go in and manually design it. Now, if we're not going to do additive manufacturing, maybe we want to run a milling simulation on it. So we want to try using milling technology in the CNC machining instead of going and using the additive manufacturing. So here we can use the same process to design a milled part. And then we can compare the results in terms of weight, in terms of tensile strength or other mechanical properties, and see what the cost will be and make our decision on what design of part we're gonna use. Most often, it's not the one designed by the human. Now, other ways to reduce weight is to change the materials that we're using. So instead of using solid materials like aluminum or wood or some things like that, often engineers will turn to products like composites. Composites, of course, many of you know, very highly used in the aerospace industry, especially in high stress areas, such as the propeller blades that we're looking at here. The 3D Experience platform does support all the specialized disciplines like composites design, and that can allow you to enhance the composites engineering definition, but also take into account the earliest stage manufacturing constraints, so that you're not finding out things at the end, but you're working for them in the beginning. There's a digital continuity between composites and mechanical associated simulations, so we can iterate very quickly on this composite design. Manufacturing is also in the loop to assess the manufacturability of what is being designed. Now, as we put in a multidisciplinary team that will work on their specific expertise, we might have one DMU, or we're going to have one DMU. Starting with mechanical design. Here we're seeing different simulations of how that rotor is actually going to turn, and we can plot out some charts and graphs to allow us to understand the kinematic results, so that we can make maybe modifications in some of the systems that are involved or in some of the mechanical features in order to get the right product. The results of all of these things can of course be shared with inside the company inside of a widget. Here we're now looking at the electrical design. So in almost every aircraft, you're going to have some electrical cabling. Of course, there are standards in the aerospace industry like EWIS. They're fully supported by the 3D Experience platform. So you can have that knowledge about how your cables should be run, how close they can be to other cables or other piping and things like that in the platform, and how they connect up to your battery pack. Of course, the battery pack is the critical part of any electric vehicle, electric aircraft, but also in terms of space. So inside the 3D Experience platform, we can do battery cell design, we can do battery pack design, or even battery system architecture. We virtually eliminate performance, can virtually evaluate the performance of a battery without really needing to do a physical test. We can do drop tests. As you see here, you can see different types of drop tests, different shapes, and we can do that very quickly on a lot of different use cases. We can also do thermal runway testing and see how that affects the different cells, and we can control and isolate, try different options to control and isolate that thermal runway. Also, we can simulate the cooling channels between the cells and see how the air is going to flow between them. Now, the optimization of these designs requires an exploration to look at hundreds of thousands of design alternatives. We're of course going to compare these design alternatives for our battery pack based on KPI criteria. Now we can narrow down the design space and only go after really the top performing battery packs for our product. Almost at the end, of course, whenever we want to fly in an aircraft, we have to throw a frozen chicken at it. It's the most common euphemism. What we're doing is we're going to simulate an impact, a bird impact. And we can do that. We can look at the stresses that are on the front windscreen, and we can use that. Since this simulation has already been run, engineers can come in and look at the simulation and see if their designs, the windscreen, are actually going to be able to withstand it, but also be able to see where that impact is going to lead and if it's going to be a problem for other parts of the aircraft. So we can not only go in and look at the impact of the shield itself, we can also go in and see where those where the vectors of the parts coming off were the probable vectors, and would they get caught in things like rotors or other air-taken valves or things like that. Finally, planning for growth. Once we have the weight back under control, we're going to stay on target to execution, and we're going to actually manufacture the aircraft. So here we see some robotic design tools going through and simulating the robotic creation of the wingtips. This is one option we have for manufacturing. You can actually go in and simulate all the tool paths, all the robotics with a library. But in some cases, we may not actually want to do the manufacturing in-house, especially when we're in the prototype phase. So in that case, the 3D Experience platform has built into it a product called Make. And basically it allows you to go in and investigate companies that do 3D printing, CNC machining, etc., and get quotes for them, see their capabilities and get quotes from them in real time in the platform. So when you go in, you can select the types of materials they use. You can see what type of machines they have. You can select different material grades. You can load in your geometry directly into the platform, into the 3D Make, and send it off for a quote. So Reinvent the Sky, especially for VTOL aircraft, but also for commercial aircraft and for space, allows you to cut time to prototype by 50%, up to 50%. You can reach certification on time, provide a unique customer experience, and of course, in terms of financial constraints, you have a lot of agility with the cloud-based solution. With that, I'm going to open this up to questions. So I think the first question we have here from Sequoia is, we keep showing CATIA on the screen, but your company probably uses SolidWorks. That's probably it. So the 3D Experience platform is a multi-CAD platform. You can do your mechanical design in SolidWorks. A lot of your small parts and things like that will be done in SolidWorks. And then a lot of your system design can be done in 3D Experience with CATIA. The two work together. CATIA can visualize and include in the digital mock-up and product structure the SolidWorks parts, and include them also in the full traceability of the product. So there's no problem using SolidWorks with this as well for the base mechanical design. Doing composites in SolidWorks will be a little bit more complex. So I'd suggest using CATIA for that. Is the 3D Experience platform capable of doing battery systems design? So we touched on that briefly, but there is a whole domain of battery libraries and things like that available on the 3D Experience platform in the cloud that allows us to go from battery chemistry simulations and battery design, cell design, up to battery pack design. As you saw a lot of things around battery pack, but then we can also lay out the entire system, the electrical system, and the battery system. So you can see, for example, if I change my motor, what's the impact on the draw on my battery as it goes through all the different components. So for example, if I change a motor or if I change a battery pack, I want to size my battery pack for the mission I have in place. So that's all possible in the 3D Experience platform and in the cloud. Any other questions? Okay, I don't see any other questions right now on this. So if you all have any questions, feel free to participate in the comments section in LinkedIn or in Facebook or in YouTube, where this will be posted. Feel free to give us reactions, ask us questions, and if you'd like to know more, just reach out to us. Thanks, everybody. Have a great day.